Good day, everyone. Today I am your presenter for today's discussion. By the way, I am Behic. Today, I am going to present a topic in mathematics and I will use ICT tools in presenting, namely laptop, projector, and PowerPoint presentation. So, for today's discussion, the topic is all about binomial theorem. But before that, let me introduce to you the objectives for this lesson. So, at the end of the discussion, the students will be able to, first, define the meaning of binomial theorem. Second, perform the expansion of binomial using the binomial theorem. And lastly, apply Pascal's triangle in the binomial theorem. Okay, let's proceed. So, what is binomial theorem? An expression in the form a plus b is called a binomial. And statement that for any positive integer n, the nth power of the sum of two numbers a and b may be expressed as the sum of n plus 1 terms of the form. So I will explain and elaborate this later as the discussion goes on for you to understand the statements. Let's proceed. Now we have the pattern of the expansion of binomial theorem. So, the first pattern we have, there are n plus 1 terms. The first is a raised to n and the last is b raised to n. So, we have an example. First, we have x plus y raised to 0. Since the exponent here is 0, this is our n. So, n plus 1, we have 0 plus 1. There are 1 term. So, only 1 term because our n here is 0. For another example, we have x plus y raised to 1 equals x plus y itself. So, in this example, our n here is 1 or our exponent. So, since 1 is our exponent, 1 plus 1, we have 2 terms, the x and the y. Next, we have x plus y squared equals x squared plus 2xy plus y squared. In this example, our n is 2. So, 2 plus 1, we have 3 terms, the x squared, 2xy, and y squared. We have 1, 2, 3. So, we have 3 terms. Next, we have x plus y cubed. Since the exponent or our n here is 3, so n plus 1 or 3 plus 1, we have 4. 4 terms we have. So the answer in this expression, we have x cubed plus 3x squared y plus 3xy squared plus y cubed. So 1, 2, 3, 4. There are 4 terms. So if you are given this expression, we have x plus y raised to 9. So, the number of terms is 10 because our n here is 9. 9 plus 1, we have 10 terms. And for this statement, the first is a raised to n and the last is b raised to n. Try to look at this example. We have x plus y squared equals x squared plus 2xy plus y squared. So, the first is a raised to n and the last is b raised to n. Since our n here, in this example, we have 2. So, our a, which is x squared, since our n is 2. So, our a raised to the n. Since our a here, in this example, is x and our b is y and our n is 2, we have x squared and the last is y squared because x is our a and y is our b and our exponent is or our n is 2. So next example, we have x plus y cubed is equal to, so our first term we have x cubed because our a is x and our n is 3, we have x cubed. And for the last term we have our b, which is y, we have y cubed because our exponent is 3. Okay, let's proceed to the next pattern. The exponent of A decreases by 1 for each term, and the exponent of B increases by 1. So let's have an example. Examples, we have E plus F squared equals E squared plus 2EF plus F squared. So from this pattern, as you notice, exponent of A, which is E, decreases, and the exponent of B, which is F, increases. So as you notice, from 2, our A here is E, from 2, in the next term, it becomes 1. And from 0, our B here is F, from 0, in the next term, it becomes 1. So 2EF plus, for the next term, we have our E here will become 0 and our F will become 2. So we have F squared. Next example, we have E plus F cubed is equal to E cubed plus 3E squared F plus 3EF squared plus F cubed. So the exponent of A decreases by 1 in each term, and the exponent of B increases by 1. So from 3 in the next term, it becomes 2, and our F here from 0 for the next term, it becomes 1. So we don't need to put 1 here because that is understood. So from 3 in the next term, it becomes 2, and from 0, the exponent in the next term becomes 1. And from here, from the exponent E squared, in the next term, it becomes 1. And from 1, for the next term, it becomes 2 or F squared. And plus F cubed, because the exponent of E, from 1, it becomes 0. And the exponent of F, which is 2, it increased, so it becomes 3. So this is the final answer of E plus F cubed. So we have E cubed plus 3E squared F plus 3EF squared plus F cubed. So next example, we have E plus F raised to 4 equals E raised to 4 plus 4E cubed F plus 6E squared F squared plus 4E F cubed plus F raised to 4. So as you notice, in this example, the exponent of A decreases, which is E. So from 4, in the next term, it becomes 3. From 3, it becomes 2. And from 2, for the next term, it becomes 1. And from 1, it becomes 0. So we don't need to put 0 there. And for the B, which is our F, so from 0, in the next term, it becomes 1. The exponent is 1. And from 1, for the next term, it becomes 2 because it is increases. From 2, for the next term, it becomes 3. That's why the answer is 4E F cubed. And for the last term, our F here is 4 because from 3 plus 1, because it increases, the answer is F raised to 4. Okay, let's proceed. The sum of the exponents in each term is n. So examples, we have A plus B squared is equal to A squared plus 2AB plus B squared. So as you notice, in this example, in the first example, the sum of the exponent in each term is n. So each exponent in each term is n. So since our exponent is 2, we have A squared. So the exponent is 2 plus 2AB. The exponent of A is 1 and the exponent of B is 1. We don't need to put 1 there. So 1 plus 1, the exponent is 2 plus B squared. So in this example, the sum of exponent in each term is 2 since our n here is 2. Next example, we have a plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. So, here, our n is 3. That's why the sum of the exponent in each term is n. So, since our n is 3, we have a cubed. So, the exponent is 3. Plus 3a squared b, 2 plus 1, from the exponent of b, 1, we have 3. Plus 3ab squared, 1 plus 2, we have 3. And plus b cubed, the exponent is 3. So, our n is 3. For the next example, we have a plus b raised to 4 is equal to a raised to 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b raised to 4. So here, in this example, the n here is 4. And as you can notice, each term, the sum of the exponent is 4 because our n is 4. So a raised to 4, 4a cubed b. So 3 plus 1, we have 4, our n. A squared, b squared, 2 plus 2 equals 4, equals our n. Plus 4ab cubed, from a, we have 1, and 3 for b, we have 1 plus 3, the exponent is 4. So, in this example, the sum of the exponent in each term is 4, since our n here is 4. Okay. Now, let's proceed to Pascal's triangle. In Pascal's triangle, it can help you to find the coefficient from row 0 and so on. So, here, row 0, our n here is 0. So, n plus 1, we have only one term. So, the coefficient in row 0 is only 1. And then, in row 1, so n plus 1, our n here is 1. N plus 1, we have 2 because 1 plus 1 is equal to 2. And that 2 terms, the coefficient is 1 and 1. In row 2, there are 3 terms because n plus 1, our n is 2. 2 plus 1, we have 3. So the coefficient 1, 2, and 1. In row 3, we have 4 terms and the coefficient are 1, 3, 3, and 1. In row 4, we have 5 terms and the coefficient are 1, 4, 6, 4, and 1, and so on. Now, let's have an example applying this Pascal's triangle using the coefficient. Okay, for this given expression, we have e plus f raised to 4. Since our n here is 4, we are using the row 4. And it has 5 terms because 4 plus 1 is equal to 5. And the coefficient are 1, 4, 6, 4, and 1. So, here we have to distribute the value of a and b in the coefficient given. So, 1 e raised to 4 plus 4e cubed f plus 6e squared f squared plus 4e f cubed plus 1f raised to 4. So, as you notice, in this example, our n is 4. So, since our n here is 4, the sum of the exponent in each term is equal to 4. So, we have e raised to 4, 4e cubed f, so 3 plus 1, 1 in the exponent of f, we have 4, 2 plus 2 is equal to 4, 1 plus 3 is 4, and the first and the last term is the exponent is equal to n, which is 4. So, as you notice also, the exponent of a decreases, which is e. So, from 4, in the next term, it becomes 3. So, it decreases. And the exponent of b, which is f, from 0, in the next term, it becomes 1. So, it increases. So, From 1, the next term it becomes 2. From 3, in the next term it becomes 2 because it decreases. And from 2, it decreases, so it becomes 1. And from 2, it increases, it becomes 3, and so on. So, the answer of e plus f raised to 4 is equal to e raised to 4 plus 4e cubed f plus 6e squared f squared plus 4e f cubed plus f raised to 4. So, let's proceed to another example. So, the coefficients are 1, 5, 10, 10, 5, and 1. So, the given expression is a plus 3 raised to 5. Since our n is 5, we have 6 terms. So, 5 plus 1, we have 6. And that term, the coefficients are 1, 5, 10, 10, 5, and 1. So, first, we have to distribute the a and b to our coefficients. So, 1 times a raised to 5 times our b, which is 3 raised to 0 plus 5 times a raised to 4 times 3 raised to 1 plus 10 times a cubed times 3 squared plus 10 times a squared times 3 cubed plus 5 times a raised to 1 times 3 raised to 4 plus 1 times a raised to 0 times 3 raised to 5. So, as you notice, we use the pattern earlier. So, our n is 5. So, the sum of each exponent is also 5. And our a, the exponent of our a decreases and the exponent of our b increases. So, from 5 in the next term, it becomes 4. And from 0 in the next term, it becomes 1, and so on. So, let's simplify this answer. We have a plus 3 raised to 5 equals a raised to 5 because 1 times a raised to 5 is equal to a raised to 5 times 3 raised to 0. Any number or variable that the exponent is 0, it is equal to 1. So, we have a raised to 5 plus the product of 5 times a raised to 4 times 3 raised to 1 is equal to 15a raised to 4 plus 10a cubed times 3 squared. We have the answer 90a cubed plus 270a squared because 10 times a squared times 3 cubed is equal to 270a squared plus 405a because 5 times a raised to 1 times 3 raised to 4, the answer is 405a, plus the product of 1 times a raised to 0 times 3 raised to 5, the answer is 243. So, the final answer for this expression, a plus 3 raised to 5 is equal to a raised to 5 plus 15a raised to 4 plus 90a cubed plus 270a squared plus 405a plus 243. Okay, let's proceed to another example for you to understand. So, we have the coefficient from Pascal's triangle. We have 1, 3, 3, and 1. So, from this given expression, 5 minus x cubed. Our a here is 5 and our b is negative x. So, since our n is 3, there are 4 terms because 3 plus 1 equals 4. And the coefficient in each term, we have 1, 3, 3, and 1. So first, distribute the value of a and b to the coefficient. We have 1 times 5, which is our a, cubed, times the value of our b, which is negative x raised to 0, plus 3 times 5 squared, times negative x raised to 1 plus 3 times 5 raised to 1 times negative x squared plus 1 times 5 raised to 0 times negative x cubed. So, as you notice, the pattern is used in this example. The n is 3, so the sum of each exponent in each term is also 3. And the exponent of A decreases and the exponent of B increases. So from 3, in the next term, it becomes 2 because it decreases. From 0, in the next term, it increases, so it becomes 1, and so on. So let's simplify this answer. We have 5 minus x cubed is equal to 125 because 1 times 5 cubed times negative x raised to 0, the answer is 125. Minus the product of 3 times 5 squared times negative x raised to 1, the answer is negative 75x. Plus the product of 3 times 5 raised to 1 times negative x squared, so the answer is positive 15x squared. Minus the product of 1 times 5 raised to 0 times negative x cubed. So the answer is negative x cubed. The final answer for this expression, 5 minus x cubed is equal to 125 minus 75x plus 15x squared minus x cubed. Okay, let's proceed to another example. We have 7 coefficient. 1, 6, 15, 20, 15, 6, and 1. For this given expression, we have a plus 5x raised to 6. So, since our n is 6, there are 7 terms. And that 7 terms, the coefficient is 1, 6, 15, 20, 15, 6, and 1. So, first, let's distribute the a and b in the coefficients. So we have 1 times a raised to 6 times 5x, which is our b, raised to 0, plus 6 plus 6 times a raised to 5 times 5x raised to 1 plus 15a raised to 4 times 5x squared plus 20 times a cubed times 5x cubed plus 15a squared times 5x raised to 4 plus 6 times a raised to 1 times 5x raised to 5 plus 1, which is our coefficient, times a raised to 0 times 5x raised to 6. So, as you notice, our n is 6. So, since our n is 6, the sum of the exponent in each term is also 6. And the exponent of a decreases and the exponent of b increases. From 6, the next term it becomes 5 because it decreases. And from 0, it increases. So, for the next term it becomes 1 and so on. So, let's simplify this answer. We have a plus 5x raised to 6. So, the answer is a raised to 6 because 1 times a raised to 6 is equal to a raised to 6 times 5x raised to 0 or equal to 1 because any number or variable that the exponent is 0 is equal to 1. So, we have a raised to 6 plus 6 times a raised to 5 times 5x raised to 1. The answer is 30a raised to 5x plus the product of 15 times a raised to 4 times 5x squared. The answer is 375 a raised to 4x squared plus the product of 20 times a cubed times 5x cubed. The answer is 2500a cubed x cubed plus the product of 15 times a squared times 5x raised to 4. The answer is 9375a squared x raised to 4 plus the product of 6 times a raised to 1 times 5x raised to 5. The answer is 18,750 a raised to 1 and x raised to 5. So, plus the product of 1 times a raised to 0 times 5x raised to 6. The answer is 15,625 x raised to 6. So, the answer in this expression, a plus 5x raised to 6, we have a raised to 6 plus 30a raised to 5x plus 375a raised to 4 x squared plus 2,508 cube x cubed plus 9,375a squared x raised to 4 plus 18,750 a raised to 1 x raised to 5 plus 15,625 x raised to 6. So, next example. We have 6 coefficient and that is 1, 5, 10, 10, 5, and 1. For this given expression, 2x minus 3y raised to 5. Since our n is 5, we have 6 term because 5 plus 1, we have 6. And that 6 terms, the coefficient are 1, 5, 10, 10, 5, and 1 from Pascal's triangle. We use the row 5. So, first, we have to distribute the a, which is 2x, and the b, which is negative 3y, to our coefficient. So, we have 1 times 2x raised to 5 times negative 3y raised to 0 plus 5 times 2x raised to 4 times negative 3y raised to 1 plus 10 times 2x cubed times negative 3y squared plus 10 times 2x squared times negative 3y cubed plus 5 times 2x raised to 1 times negative 3y raised to 4 plus 1 times 2x raised to 0 times negative 3y raised to 5. So, as you notice, we apply the pattern earlier. So, since our n is 5, the sum of the exponent in each term is also 5. And the exponent of a decreases and the exponent of b increases. From 5, it decreases. So, in the next term, it becomes 4. From 0, in the next term, it becomes 1 because it increases and so on. So, let's simplify this answer. We have 2x minus 3y raised to 5. So, is equal to 32x raised to 5 because 1 times 2x raised to 5 times negative 3y raised to 0, the answer is 32x raised to 5. Minus the product of 5 times 2x raised to 4 times negative 3y raised to 1, we have negative 240x raised to 4y plus the product of 10 times 2x cubed times negative 3y squared, we have 720x cubed y squared minus the product of 10 times 2x squared times negative 3y cubed. So, the answer is negative 1080 x squared y cubed plus the product of 5 times 2x raised to 1 times negative 3y raised to 4 is equal to 810x y raised to 4 and minus the product of 1 times 2x raised to 0 times negative 3y raised to 5. So, the answer is negative 243y 5. So, the answer for this expression 2x minus 3y raised to 5 is equal to 32x raised to 5 minus 240x raised to 4y plus 720x cubed y squared minus 1080 x squared y cubed plus 810x y raised to 4 minus 243 y raised to 5. Okay, since we are done discussing on how to solve the binomial theorem using the Pascal's triangle, before I will end this video, you need to try this at home. So, solve the following. I give you 3 items three expression. First, we have 9 minus 3z raised to 7. And for number 2, we have 5x minus 3y raised to 4. For number 3, we have x minus 3y raised to 5. So, you can solve it using the Pascal's triangle for the binomial expansion and use the pattern that we've discussed earlier. And that would be all. Thank you.